to elimination. So we are trying to eliminate one of the variables when our system is in standard form. So in order to use elimination, it has to be in standard form where the x terms are lined up plus or minus the y terms equals the constant. It has to be in that form to use elimination. Then we're going to look at our coefficients of our x values to see, can I cancel out those x values if I add them together? So in this case, we have a 4x and a negative 4x. So if I added those together, 4 plus negative 4 is 0. And it would cancel out or eliminate. If I look at my y values, if I added 8 plus 2, I just get 10, and nothing has been eliminated. So I'm going to end up canceling out or eliminating the x values, okay, because the coefficients are already opposites of each other. That's what we want. We want the coefficients to be opposites of each other, okay? So I'm going to go ahead and add the two equations together. So 4x plus negative 4x is just 0, so I'm just going to cross it out, which is eliminating the x variable. Then I'm going to add 8y plus 2y, and we get 10y. And then we're going to add 20 plus negative 30, and we get a negative 10. Now it's a one-step equation so that I can just solve by dividing by 10. And y equals negative 1. But I'm not finished because I have to go back and find my x value. You can either go back to the first equation or the second equation. It does not matter. And you're going to substitute negative 1 in place of y. So I'm going to use the first equation, and I'm going to have 4x plus 8 times negative 1 equals 20. Okay, so now I have to multiply 8 times negative 1, and I get negative 8. Bring down the 4x. Okay, plus 8 on both sides. And we get 28. Hold on. And then we're going to divide by 4. And get x equals 7. Our final answer is the coordinate point x, comma, y. The x comes first, so it's 7, comma, negative 1. For number 3, we have x minus y equals 11, and 2x plus y equals 19. So first check, are the two equations in standard form? The x values are lined up, the y values are lined up, equals the constant. Okay, so now I'm going to look at my x values and see if the coefficients are opposite of each other. So this is an understood 1, and this is a 2x. So those are not opposites, so let's look at the y value. This is a negative 1y, and this is a positive 1y. So those are opposites of each other, so when I add them together, they will cancel out. So we're going to add 1x plus 3x, 1x plus 2x is 3x. 1y, or negative 1y, plus positive 1y eliminates or cancels out, equals 11 plus 19, which is 30. Now it becomes a one-step equation so that we can solve for x by dividing by 3, and we get x equals 10. We have to go back and solve for y. You can either use the first one or the second one, doesn't matter. I usually use the first one just to keep a habit, but it doesn't matter. Okay? So I'm going to take the first equation, and it was a 1x So I'm going to put 10 because x equals 10 minus y equals 11. I substituted 10 in place of x. 10 in place of x. I substituted the 10 in place of the x value.
So you put 1 in front of the y too?
You could put a 1 there, yep. So now I'm going to subtract 10, and I get negative 1 equals negative 1y. And it's a one-step equation, so I'm going to divide by negative 1, and y equals positive 1. I have to write it in a coordinate point, x, comma, y. So the x comes first, which was 10, and the y comes second, which is the 1. So the point where the two lines cross or intersect is 10, 1. Hey, this should be a positive 1 here. So our answer should be negative 1 there. Thank you for correcting me. 11 minus 10 is a positive 1.
Oh, I was right.
Then we divide by negative 1, and so we have negative 1. Number 6, we have 8x plus y equals negative 16, and a negative 3x plus y equals negative 5. If we look, it is in standard form. Now I have to decide if I'm going to eliminate the x or if I'm going to eliminate the y's. Okay? So, I have 8x and I have a negative 3x. I would have to do 2 multiplications to make those even. Okay? Or my y values, I have a 1y and a 1y. So I could just take one of these equations and multiply by negative 1 so that they become opposites. It does not matter if you multiply the first equation by negative 1 or the second equation by negative 1. Because both of these numbers, coefficients, are the same, I need one of them to be the opposite. Okay, so let's take the first equation, and I'm going to multiply the entire equation by negative 1. I'm going to multiply the entire equation by negative 1. So now that I'm multiplying by negative 1, I'm saying negative 1 times 8x is a negative 8x. Negative 1 times 1y is a negative 1y. Negative 1 times negative 16 is a positive 16. Now, I do not need to do anything to the second equation for this problem. So I'm just going to move over my negative 3x plus 1y equals negative 5. I'm going to add the two equations together. 8, and that's a negative 8 plus negative 3 becomes a negative 11x. 8 plus 3 is 11, so that's a negative 11. 1y, or negative 1y, plus positive 1y eliminates, leaving me with 16 plus negative 5, which is 11. Our final step is to divide by negative 11, and we get x equals negative 1. That's my x value, but now I have to find the y value. So I'm going to either use the first equation or the second equation and substitute negative 1 in place of x. Okay? So I'm going to go back and I'm going to say 8 times negative 1 plus y equals negative 16. Eight times negative 1 is a negative 8. Now I need to add, because it's a -8, I'm going to add it to the other side. So I get y equals -8. So my answer is the coordinate point -1, -8.
Oh, wow.
I can get negative.
But I